Hi, team. Thank you for showing up for your learning once again. Today, we are reviewing chapter 1.7 in the textbook, and this is on page 71 in the chapter test. So I'll show you the questions that we're going to be looking at here. First, we have determine the points of intersection but for each pair of functions. We have quadratic functions here, so we know those are going to make some kind of parabola, and then some lines. So that could cross the parabola in as many as 2 points and as few as 0 points. Right? And the discriminant determines how many, and we'll talk about that over here. So here, this one, for what value of b will this line be a tangent to the parabola here? So this question is a little trickier. We're going to talk about that too, and we can use the discriminant to solve that type of question. So the first step with these questions is copy them out. So here is question 15a up there. I have my quadratic and my line. So you could visualize these right away, or you could just go ahead and get started on cranking them. All right, so if these two intersect, then y is going to equal y and x is going to equal x. So that allows us to set them equal to one another. 5x minus 4 is equal to 4x squared minus 15x plus 20. Okay, subtract 5x and add 4 to both sides. Subtract 5x, add 4. I want this to be equal to 0 on one side because I get to do all kinds of fancy tricks when it's equal to 0. So subtract 5x and add 4. Notice that I line up my inverse operations underneath the common terms where I'm going to be collecting those in. So I have 0 is equal to 4x squared minus 20x plus 24. I could go ahead and crank quadratic formula at this point and find where does that equal 0. Why do I know I can use quadratic formula? Because I have a quadratic that's equal to 0. That's what the quadratic formula is designed to solve, is exactly this type of problem. But I'm not gonna, because there's something I can do first. I can divide both sides of the equation by 4. Now, when I do that, I'm dividing this side by 4. And what I'm saying is, if this is equal to 0, then this divided by 4 is also equal to 0. Because 0 divided by 4 is still 0. I am not saying that x squared, that's 4x squared divided by 4, minus 5x plus 6. I'm not saying that this is equal to this. I never said that. I said they're both equal to 0. So if they're both equal to 0, I can find the x values that make this 0, and that will also make those 0. Okay, I'm just looking for x values. All right. So now I'm going to bring that down. If 0 is equal to, I can factor that. Oh, that's so great. X minus 6 times x plus 1. Look at that. Negative 6 times plus 6 gives me, oh, wait, that's wrong. That's wrong. That's super wrong. Oh, my goodness, Mr. Jennings, you made a mistake. You're going to have to scritchy scratch that out. 0 is equal to, I have a positive here. That means I'm multiple, but they add to a negative number. So the trick here is when you see positive there and negative there, you're looking for two negative numbers because they multiply to give you something positive, they add to give you something negative. So those numbers are 2 and 3. X minus 2 times x minus 3. Okay, there's my roots. So then, if 0 is equal to x minus 2 or x minus 3, then x minus 2 equals 0 or x minus 3 equals 0. One of those two things has to be true. So that these two equations that I get, this one equals 0 or that one equals 0. And those are the only two ways to make a 0 here. So I take those two equations and I can say, well, x is equal to 2 or 3. Those are the two values of x. So let's try, let's use the line here. Y is equal to 5x minus 4, but instead I'm going to sub in 2. And then I get y is equal to 10 minus 4 is 6. So therefore, that gives me the point 2, 6. And then over here, y is equal to 5x minus 4, but I'm going to use 3. 5 times 3 minus 4. Okay, and that's a y is equal to 15 minus 4 is equal to 11. So the other solution is 3, 11. Okay, so now, therefore, the quadratic and the line, that's an awkward way to write this. I would say the two functions meet at, or the 2 points of intersection are 2, 6 and 3, 11. right? So that's how we would answer one like this. We recognize what we're looking for, where this is equal to that. So I set them equal to one another. Then I move everything over to one side so that I have something equal to 0. Before I crank that and try and factor it, I can divide both sides by something, and then I can get this. Okay, that will factor. It factors this way, not that way. That would be if this was -6, but this is not. It's +6. So there. And then boop, boop. Then we get those two x values. You input those x values into one and either one of these equations, and then they will give you your solutions. To check your answers, check them both in here in the quadratic. So let's see, 2, 6. Okay, so if that's 2, 6, so I put in 2 for x. 4 times 2 squared is 16. Minus 15 times 2 is 30. So 16 minus 30 gives us minus 14, plus 20 is plus 6. And that's indeed what we got there, 6. All right, now let's check this one, 3 and 11. 4 times 3 squared gives us 4 times 9 is 36. Minus 15 times 3, so minus 45. So 36 minus 45 gives us negative 9. Negative 9 plus 20 is 11. So that's that point there. All right, so I've just checked those. If you want, you can write that out and do your substitutions to check both points and make sure they satisfy both equations. If they do, then you got 100% of the marks. You got it. Okay. All right, unless you made mistakes in other places. Okay, here we go, another one. So again, same steps. My prediction is this one's not going to factor. We're going to need quadratic formula. All right, so I have this is equal to that, so set it equal. Negative 3x minus 5 is equal to negative 2x squared plus 9x plus 9. Move everything to one side of the equation. Add 3x, add 5. Add 3x, add 5. Okay, 0 is equal to negative 2x squared plus 12x plus 14. Divide both sides by negative 2. In fact, I just really need to divide the one side, because dividing 0 by negative 2 gives me 0. Okay, this 0 is equal to x squared minus 6x minus 7. So now I'm looking for things that multiply to negative 7 and add to negative 6. Indeed, it does factor. It factors into what I was trying to factor the other one into. X minus 7 times x plus 1. Okay, and there's my x values, flip the signs. If I need quadratic formula here, if I can't factor it, I can still use quadratic formula. So I'm going to use quadratic formula anyway, just to show you you can do it. A is equal to 1. B is equal to negative 6. C is equal to negative 7. And this should output values of 7 and negative 1. All right? Yeah, 7 and negative 1 should be the values that I get here. Okay, so let's see. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, x is equal to negative b is 6 plus or minus the square root of 36 minus 4 times 1 is still minus 4 times minus 7 is 28, positive 28. So 36 plus 28. Okay, all over 2 times a, which is 2. Okay, 36 plus 28 is 64. Okay, so, and the square root of 64 is 8. Great. So this would be x is equal to 6 plus or minus 8 over 2. Or x is equal to 3 plus or minus 4 over 2. X is equal to 3 plus or minus 4. X is equal to what did I say? Negative 1. Or x is equal to 7. Okay, those are my two values. 3 plus or minus 4 is negative 1 or 7. Cool. Now I find my y values. Use the line here. Y is equal to negative 3x minus 5. And I have 1 is at negative 1. So y is equal to negative 3 times negative 1 minus 5. So y is equal to positive 3 minus 5 is negative 2. And then over here, the other option was y is equal to negative 3 times 7 minus 5. Okay? Negative 3 times 7 is negative 21 minus 5. Y is equal to negative 26. Okay, and that gives me my 2 points. Therefore, the points of intersection are -1, -2, and 7, -26. Okay? And that's using quadratic formula to find it. Factoring also gave it to us faster. All right, so that's how you do those types of questions. This type of question is harder. This type of question is very challenging. Okay, this would be a good thinking question on the test, but it's not on the test. But I'll show you how to do it anyway. Okay, here you go. It's not on the test this year. Maybe you're watching this video in another year, and I did put this question on the test, so you need to know it anyway. Okay, here we go. Okay, here we go. So, for what values of b will this be a tangent line to this? Let's visualize in Desmos to take a look. So, I'm going to put these into Desmos. Okay, here is our line and our quadratic. Now, our line has a b that's undefined, meaning that we don't know b. We want to solve for b such that I can move this line around and oh, that's two solutions, still has two solutions, still has two solutions, still has two. Oh, there it is, the -4. Okay, so -4 seems to be the answer. If we zoom in here, we'll find one and only one point of intersection right there. That's indeed the right place for it to touch. But we want to prove that that's the case, that this is now a tangent line. And then, if we go too far down, or the b that's too small, it won't touch. So what we're doing is we're finding a spot where there's one and exactly one solution. That's you see with different values of b, that's one and exactly one solution. Anything bigger than that, and we're hitting the parabola in a couple points. See, boop, boop. Anything bigger than -4, it's going to see still touches at 2 points in there. There, I really need to zoom in, but you can see it there, boop and boop, and that's really close to -4. Now, so let's see how you could find that algebraically, because sometimes the numbers are not going to work out so nice where you can just fudge factor it in Desmos. That's called fudge factor, what I'm showing you there. Fudge factor is really useful to help you understand what you're looking for. But we've got a line. We don't know how high that line needs to be so that it touches the parabola at one and exactly 1 point. All right. The trick is to use the discriminant. Okay, the discriminant, b squared minus 4ac, gives you information about the number of solutions. If this is greater than 0, then there's 2 solutions. If b squared minus 4ac is less than 0, then there are 0 solutions. And if b squared minus 4ac is exactly equal to 0, then you have a 1 solution situation. So we want this to be exactly true. All right, that we're going to put in some value of b that makes that true. All right, so let's do the work like we were going to find the intersection between this line. We're going to pretend that b is a number, because it is. It's actually -4, but we're going to find out that it is that. So we set them equal to each other. -2x plus b is equal to 3x squared plus 4x minus 1. Okay, bring this down another line. 0 is equal to 3x squared plus, where's my inverse operations pen? Plus 2x plus 2x. I was going to skip that, but I shouldn't do that. And minus b. Okay, minus b. Okay, so that's equal to plus 6x minus 1 minus b. Okay, there's my c right there. Is -1 minus b. Together, that's c. Okay, now let's see what b is going to be when I crank it into the discriminant. All right, so now if I know that the discriminant has to be 0, because I want this line to touch this quadratic in 1 point and only 1 point. So that means there should be 1 solution to this and not 2 and not 0. So that means this has to be 0. So let's put that in there. B squared is 6. So I'm just going to write out the discriminant. B squared minus 4ac is equal to 0. Okay, now put in the things. So b squared is 6 squared in this case, minus 4 times 3 times c. C is -1 minus b. Okay, that's equal to 0. Now we have one equation, one unknown, solve for b. So let's do exactly that. All right, so simplify. So this would be 36 minus 4 times 3 is 12. So minus 12 times negative 1 times negative b. Okay, now let's distribute this minus 12 here into the negative 1, negative b. Distribute that in. Okay, so we have, this is equal to 0. So we have 36, negative 12 times negative 1. So that's plus 12. Negative 12 times negative b is plus 12b is equal to 0. Okay, 36 plus 12 is 48. So let's subtract 48 from both sides. All right, then we have 12b is equal to negative 48. Oh, divide both sides by 12. B is equal to negative 4. That's what Desmos showed us. Yay! So therefore, the value of b is equal to negative 4 is the value that would make that line a tangent to the parabola. Just a definition review, tangent means it touches at one and only one point. If it touches at 2 points, it's called a secant. If it touches at no points, then it's called a line that doesn't touch the quadratic. Okay, it's like, we don't have a name for that, as far as I know. A non-coincidental line. The last questions. Do all linear quadratic systems result in a solution? No, they don't. Sometimes there's zero solutions. We get that when the discriminant is less than 0, because we can't take the square root of a negative number. This discriminant here, b squared minus 4ac, okay? When it's less than 0, that would mean that your quadratic formula, and I have an example of the quadratic formula right here, we did it, that would be asking me to take the square root of a negative number, and we don't do that. Okay, we don't do square roots of negative numbers. Give me two numbers that multiply together to a negative number. No, this is they don't. They don't. It's not the real numbers. So there are no solutions to those. So it's easy to create situations where there's no solution. Also, I'll give you a real life example. There, okay, that line doesn't touch the quadratic. Very easy to see. The quadratic is going to slope up way faster up going that way. Slopes up way faster than the line, so it's never touches it, okay? There's no solution, all right? So yes, there's oftentimes situations where a linear quadratic system will not have a solution. All right, everyone, I hope that helped answer some of your questions. If you have unanswered questions, you email me now, and I will help you very quickly. I'm very good at getting back to emails, or ask me in class. And bye for now, everyone. Thank you for showing up for your learning.